Is everyone ready? Let's get ready for chemistry!
Let's look at a different kind of stoichiometry problem. This one's a little bit more complicated. If I want to find the mass of calcium phosphate produced by reacting 20 grams of phosphoric acid with 20 grams of calcium hydroxide, how do I know which one to start with? Do I start with 20 grams of phosphoric acid, or do I start with 20 grams of calcium hydroxide? This is a limiting reagent problem. The thing to do here is to figure out which of these two chemicals is going to run out first. And it's not immediately obvious. You might say, oh look, they're both 20 grams, so they'll both run out at exactly the same time. But remember that mass is not comparable. You can only compare moles with moles. So what I want to do is I want to compare moles with moles by doing a stoichiometry problem. If I start with 20 grams of phosphoric acid, let's convert that into calcium hydroxide and see what happens. So moles of phosphoric acid, moles of calcium hydroxide. The ratio is 3 to 2. The molar mass of phosphoric acid is 98 grams of phosphoric acid for every 1 mole of phosphoric acid. So 98 grams of H3PO4 for every 1 mole of H3PO4. Grams cancels with grams, moles cancels with moles. We're left with moles of calcium hydroxide, but we want to compare that to grams of calcium hydroxide. The molar mass of calcium hydroxide is 74.02 grams of calcium hydroxide for every 1 mole of calcium hydroxide, and we're going to plug that in so that the units cancel. 74.02 grams of calcium hydroxide for every 1 mole of calcium hydroxide gives us 20 times 3 divided by 2 divided by 98 times 74.02, 23 grams of calcium hydroxide. Now we have to figure out what that means. So 23 grams of calcium hydroxide, we have 20 grams. To react all of the phosphoric acid, we would need 23 grams. So what does that mean? That means we don't have enough calcium hydroxide to react with all of my phosphoric acid. If we don't have enough, what that means is that the calcium hydroxide is limiting. We are going to run out of calcium hydroxide first. So that's the limiting reagent. And what that means is, from now on, whenever we do a stoichiometry problem with this, we're going to have to start with the 20 grams of calcium hydroxide, not the 20 grams of phosphoric acid. If the calcium hydroxide is limiting, that means that the phosphoric acid is in excess. Let's do that again coming the other way. Let's say if I've got 20 grams of calcium hydroxide, how many grams of phosphoric acid is that equivalent to? The ratio of phosphoric acid to calcium hydroxide is 2 to 3. To get moles to cancel with grams, we need the molar mass of calcium hydroxide. The molar mass of calcium hydroxide is 74.02 grams of calcium hydroxide for every 1 mole of calcium hydroxide. So 74.02 grams of calcium hydroxide for every 1 mole of calcium hydroxide. Grams of calcium hydroxide cancel with grams of calcium hydroxide. Moles of calcium hydroxide cancel with moles of calcium hydroxide. Then we want to convert moles of phosphoric acid into grams, and we need to use the molar mass for that. So 98 grams of phosphoric acid for every 1 mole of phosphoric acid. Moles of phosphoric acid cancel with moles of phosphoric acid, leaving us with grams of phosphoric acid. And how many grams of phosphoric acid is that? So 98 times 2 times 20 divided by 3 divided by 74.02 is 17.65, so 18 grams of phosphoric acid. What does that mean? In order to react all of the calcium hydroxide, you would need to use 18 grams. You have 20 grams. Do you have enough phosphoric acid to react with all of the calcium hydroxide? You have as much as you need. You have more than you need. So the phosphoric acid is in excess, which means that the calcium hydroxide will run out first. What does that mean? It means that the calcium hydroxide is limiting, and when you do stoichiometry from now on, you have to start with the 20 grams of calcium hydroxide. So if what I want to know is how many grams of calcium phosphate this is going to make, I have to start with 20 grams of calcium hydroxide, not the 20 grams of phosphoric acid. So now when I do the stoichiometry, I have to start with the 20 grams of calcium hydroxide, and then I'll do the mole-to-mole ratio, and I'll put calcium hydroxide on the bottom because that's my limiting reagent, and I have to start with the limiting reagent. And then I'll put calcium phosphate on top because that's what I wanted to find. And the ratio here is 1 to 3. And then I need the molar mass of calcium hydroxide, which is 74.02 grams of calcium hydroxide for every 1 mole of calcium hydroxide. And then I need the molar mass of calcium phosphate. The molar mass of calcium phosphate is 310.18 grams of calcium phosphate for every 1 mole of calcium phosphate. So when I plug that in, I have to put the moles on the bottom here. Moles of calcium phosphate for every 310.18 grams of calcium phosphate. So moles of calcium phosphate cancel with moles of calcium phosphate, grams of calcium hydroxide cancel with grams of calcium hydroxide, moles of calcium hydroxide cancel with moles of calcium hydroxide, leaving us with grams of calcium phosphate. So how much calcium phosphate would I actually make? 20 divided by 3 divided by 74.02 times 310.18 is 28 grams of calcium phosphate. Ta-da! So when you do a limiting reagent problem, you have to figure out which of these two is limiting and then start with the limiting reagent when you do your stoichiometry.
Is everyone ready? Let's get ready for chemistry! Yeah, 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 yeah.